All right, everybody. It's 2:02 on February 22nd, 2022. Seems like the right time to start our webinar here. My name is Vishal Lala. I'm the Managing Director here at Polar Racking. And today's topic is selecting and building large-scale solar for durability and performance. And we call it that because as Polar Racking, we're a Canadian company working all over North America and the Caribbean, but we pride ourselves on providing a product that's really built to last under your heaviest wind and snow conditions and the most challenging ground conditions as well. So today we'll be doing a quick overview about Polar Racking and our guests here from PRI Engineering. Talk about what makes Polar's fixed ground mount solution ideal for large projects in the most challenging areas, the importance of proper foundation, and we'll talk about install, and then we'll definitely open it up for questions. So today, presenting with me, I have Arash Yazdani from PRI Engineering, and Jonathan Mizrachi, who's our U.S. Sales Director here at Polar Racking. Arash, I'll let you introduce yourself and talk a little bit about PRI Engineering.
Yeah, thank you very much, Vishal. Always a pleasure to jump on these webinars with the Polar team. My name is Arash Yazdani. I'm the Director of Engineering, one of the founders of PRI Engineering. I'm a geotechnical engineer by training and experience. And our team at PRI Engineering is a leader in solar foundation design. We've completed hundreds of projects, predominantly in the northern parts of the world, dealing with cold climate engineering. However, we've also assisted with some projects in the Caribbean because the high loads that you see in northern environments are often easily transferable to the Caribbean environment. Our team has in-house engineers licensed in multiple of areas throughout Canada and practiced extensively in the United States. And we've fulfilled every role in a solar foundation design, from engineer of record to owner's engineer to completing quality control. And that is PRI. I'll turn it back to you, Vishal.
Yeah, thank you. Just to tell you guys a little bit about Polar Racking, we're founded in 2009, so this is our 13th year in business. We are a leader in, we're a leading solar mounting systems provider, as I mentioned before, throughout North America and the Caribbean. We have fixed ground mount, single axis tracker, which is coming, carport. We make our own foundations, ground screws, helical piles. We supply driven piles as well. We have a pretty strong team of geotechnical, structural, mechanical, and civil engineers on staff to help with project implementation. We have manufacturing capacity on our fixed ground mount of over 1 gigawatt per year. And we design product to be delivered and installed in all over Canada, the Midwest, Northeast, and the Caribbean. That's not to say that we can't do the beautiful projects in California and Texas and southern states. We just have a very, very strong solution for areas, and as I mentioned, in the Northeast or heavy winds, like you'll find all along the coast, right down to Florida. We currently have over 450 megawatts of installed base with a pretty strong pipeline of projects coming up. Our current product portfolio includes, as I mentioned, fixed ground mount, which we call our PRU, which is for projects, half a megawatt and above. PRP, which is our carports, all different types of carports. Long spans, L structures, T structures, Y structures. Again, we can provide your foundation engineering, design your pile, supply and install your carports. PRUD, which are distribution ground mount, which you can find in places like Baywa. This is for your smaller projects, generally sub 500 kilowatts, where you need to quickly deploy, and it's a standard solution, a 2x the 2x8 kit that you can quickly deploy, buy through distribution and bring to your field. Comes with a pre-engineered stamp package for various provinces and states, and a foundation guide as well to tell you which type of foundation will work depending on your wind load, your snow load, and your ground conditions. And coming soon is our single axis tracker, which we will spend a little bit more time telling you all about here in the coming months. With that, I'll turn it over to Jonathan Mizrachi, who's our Director of US Engineering, to introduce himself and tell you a little bit more about our fixed ground mount product, the PRU.
Yeah, thank you, Vishal, and thank you, Arash, as well, for joining. Excited to be here today and speak about our ground mount product here for large-scale solar systems. We have a really great and robust product that we've been speaking to quite a few developers in the marketplace and growing our customer base with that as well. So just this kind of came up because of customer questions and needs and things like that we've been speaking with over over time here. So thought it would be great to present to everybody, pull it up on a webinar, and so here we are today. So again, as Vishal mentioned, PRU intended for projects over 500 kW. We're quoting anything in between that 500 kW mark all the way up to a couple hundred megawatts on more of the utility side type of projects. Our product is, takes pride on being easy and cost effective to assemble. So fewer parts, common hardware. Those are all things we're going to talk about today. Integrated bonding, of course, simple wire management, just making things really easy and effective in the field for the installers, as well as from an actual product side and delivering this product to site. Of course, we're UL certified. We'll get into some of that as well. And we're very engineering focused, I should say, where if you have a site with maybe some different topography or challenges or something like that, I would say bring it to us. Let us take a look at it. Let our engineers get eyes on it. And, a lot of times we're able to come up with varying solutions aside from our just, common, what's down on paper. There's a few different tricks and things like that that we have used to make projects happen and effective solutions there. Next slide. So first, I wanted to talk to everyone about, what's in the ground. Arash is going to speak about that as well a bit. But really, foundations are a big part. I mean, it's the base of any system here for ground mounts, right? So we have multiple solutions, and basically what we say to all customers is we're not the screw guys, we're not the helical guys, we're not the driven post guys, right? We really come from the standpoint of what's there on site, and what's best for the system. So as you can see here, we have two different ground mount solutions, both a single post solution and a dual post solution. And then with those two different types of solutions, obviously you have different types of foundations that can be given here as well. So again, we like to take a look at the site. Where is it? What's a snow load? What's the wind load? What's the topography? What are the soil conditions? Kind of take all that information and then come up with the best solution that's both cost effective, safe, and viable for the project. Next slide. So with our system, you're going to get a few things, right? So we pride ourselves on a high degree of adjustability, greater assembly tolerances. So we're going to talk about that in some of the next slides, where adjustability is really important on site because not only are you installing a foundation, but you have posts coming out of that foundation. And then, you always need that wiggle room, right? East, west, north, south, up and down, whatever it may be. Top down or direct bolt clamping options. So we have two options. Typically in the Northeast, upper Midwest, Canada, we're seeing that the top down option is preferred because of ease of installation in the cold climates, right? So it's a little bit easier for the installers to work with a top down style clamp. We do have direct bolting clamping options that we use as well. And really the direct bolt is going to be where, we have heavier wind loads, heavier snow loads, and you need a higher PSF type of attachment. Built-in wire management, UL certified integrated bonding and grounding. So we're going to show you guys, how to place your wires in our rack. Of course, again, everything is UL certified integrated bonding. I think that's pretty self-explanatory. Customizable. So if you have a certain type of layout, certain type of preference, we'd always like to see it. And again, we spoke about multiple types of foundations with posts, helicals, ground screws, great ballast solutions as well for any landfills or anything like that. And then, of course, we also offer installation services. So we're going to kind of talk about each and every one of those points here today in greater detail. So site considerations are really important. And this is really the first step to identifying what you have on site as a solar contractor, developer, site owner, whatever it may be, right? So some things that we're going to ask you about, and sometimes, the folks that come to us don't even know, and, we can help you get to that solution. But soil conditions, obviously a geotechnical report is very important. Arash will be able to speak a little bit more in detail about that. Topology, right? So is it, on a hill, undulations in the ground? What does it look like as far as, the land itself? Of course, wind speed, snow loads are all things to take into consideration. Corrosion. So corrosion against, shorelines, Caribbean markets, anything by the sea. A lot of times customers come and ask us for a higher level of corrosion resistance. Very important there as well. Availability to install different types of foundations. So, basically I think we're saying there is, there's multiple solutions that we could use for those foundations. And then, module bonding and support, it goes along the lines with clamping that we mentioned before, where we have basically two different methods of attaching as well.
Yeah, and just to expand on the availability of equipment, as we mentioned before, we have a lot of different foundation options that we can provide you, but sometimes it'll be easier to put a ground screw in. Sometimes it'll be easier to put a German pile in, just depending on what type of equipment you have access to, or your contractor or your EPC has access to. And, we want to be sensitive to that and work with you guys to make sure that, we're specifying something that's going to be very easy to deploy. We're seeing that a lot, especially on our, we're doing 2 big landfill sites right now, total 92 megawatts. And it was easier on those specific sites to go with a precast ballast instead of a pour in place ballast. So we adjusted our design to work with our customer to accommodate that. So, and then one other thing I would mention is with respect to topology, generally we like to, we go with fixed tables instead of continuous rows. So it benefits us in a few different ways, but especially when it comes to topology, we can play with, generally we size the tables to match your string size to make it easy, electrically. But if you have, different areas in the site where we need to go with shorter tables or longer piles, those are all things that we consider when we're working with you and coming up with a design. So, which leads actually well into this slide as well. So,
yeah. So some key technical features. So just dive in a little bit deeper here. so yeah, individual tables accommodate varying topology and mitigate risk from heaving as well. So, in a site where, we may have different topologies, maybe it's on a hill and how do we accommodate that? Sometimes we go with shorter tables, right? That's one of our tricks of the trade where, we could assign different tables to, meet the topology of the site. Also, it mitigates the risk from frost heaving. So in the northern states where, maybe we're in, Maine or Minnesota, Michigan, something like that, Canada, obviously, frost heaving is something that should be considered as well. And a way to mitigate that again is by, shorter tables and, essentially keeping those tables independent of one another. So just something that's out there as well. So we're going to talk about durable galvanized steel construction. So all of our structures start at a standard of G90 galvanization. Of course, again, with sites that may be along the shoreline or maybe some other conditions that require higher galvanization, those are obviously available, and happy to take a look at those as well. Corrosion resistant hardware. Typically our hardware is magni coated. We can use stainless steel or hot dip galvanized, again, for sites that need, higher levels of corrosion resistance. So that, again, is also available. Mid clamps come with integrated bonding, similar to, a lot of other systems that you may see out there. I think that's pretty standard in the industry to see integrated bonding coming with the mid clamps, and of course always important. Wire management system, we do have a slide coming about that. How to put your wires accordingly across the rack, and then custom tilt angles, and then so we want to mention about the custom tilt angles that, typically what we see is usually like a 20-30 degree. I mean, it's probably 90% of our projects are at a 20 to 30 degree type of tilt angle. We can go, of course, lower, we can go higher again, but typically 90% of our projects are in that 20 to 30 degree type of tilt range. And, we can, of course, consider, like I said, either lower or higher tilt angles for whatever reason that may be needed. Portrait is pretty much our standard configuration that we like to go with. As you can see here in the picture, we have our rails going east-west. So naturally, we like to fit along the alongside of the panel in the sweet spots for mounting. Also helps with the, if we're direct bolting, there will be mounting holes in the back of the module. So 2 high is pretty much the standard. We can look at 3 high. Of course, we need to look at the, again, wind, snow loads, and other factors there to make sure that could work. And then, we have done landscape as well, either 4 or 6 high in landscape, and can configure that also. So, let us know what types of projects and configurations you may be looking at, and we'll be able to accommodate and kind of walk you through the strengths of maybe going with each, or what that may look like. Next slide. So here's a standard top-down view and a side view of our single post system. Again, modules in the system would be going in portrait. Something that we like to do actually is go with a round post into the ground rather than an I-beam. We have done both, obviously, but a round post does offer some more adjustability in the field, which we like to show, add some higher tolerances as well for adjustability. So this is something that, we like to show, and I think it's pretty unique in the marketplace where not a lot of our competitors are doing that. But, something we wanted to show you here for adjustability. Vishal, did you want to add anything on this slide?
Yeah, no, I think you did a good job here. Yeah, exactly. This is a typical rack. I mean, the one thing you will notice with this view, if you compare it to most of our competitors, is just the lack of additional bracing that you'll find on most other systems. You know, especially when you're building in the Northeast. You know, what we've seen, you know, from others is this layout with a lot of extra lines, which would denote, you know, bracing or strapping or whatever you want to call it, you know, throughout the tables, and you know, we achieve that by having basically thicker gauge primary members of steel, and you know, although yeah, that ultimately there's a little bit more steel in the system, but it simplifies the install, it simplifies the risk of making mistakes, you know, while installing, you know, exponentially, and you know, we're able to maintain like an extremely competitive price. So that's, you know, that's why we've gone this route. So
And one other thing to note with this design, right? It shows it there. So typically we could get up to 150-mile-per-hour wind speeds, as well up to about 50 or 60 pounds of or PSF of snow load. So this is a pretty robust system without that strapping or bracing that's needed. So fewer parts, fewer pieces, you know, some fairly good, you know, standard engineering that's coming here with that 150 mile per hours and, you know, 50 PSF or 60 PSF.
so this is a typical, just to interject here, John, this is a typical design. If you go above the 150 mile per hour, as I mentioned, we're doing more and more projects in the Caribbean. And if there's anyone here that's, you know, developing there or residing there and looking for a product, what we've been doing is going with the 6 east-west beam design, and that's primarily because that's what the module manufacturers are looking for in order to honor their warranty to you, ultimately, you know, the developer, the owner of the project. So that's, you know, that's what we are able to do and we have done. And when it's typically a direct bolt connection, in the corners, you have 6 east-west beams, and you know, generally in the Caribbean or these areas, it's lower tilts. But this is just to show you that, you know, we have done it and we are doing it and we are able to do it. So, you know, if you have those projects, we're happy to look at them. And we do have an existing solution.
Yeah, absolutely. Great points there. So racking tolerances and adjustability. I mean, this is pretty much our PRU single post adjustability. Some standard tolerances there for you guys to look at. You know, of course, again, if you have something that, you know, maybe it's undulations in the ground or, you know, different type of topography or something that may be happening there, you know, please reach out to us, let us know. But essentially you can see here the different adjustability we have, you know, up and down, north, south, east, west, etc., on top of our posts and across our beams and cross sections.
Yeah, exactly. So the tolerances here are just the typical tolerances that we include in our manual. Now, we restricted to this in our manual because we don't want everyone to go nuts with the tolerances. But as situations arise in the field and you know, and you need to have a little bit more adjustment, there is more adjustment in all of these connections. If you apply the extreme on every connection, you're going to have problems. But you know, as you're building and as you encounter issues, you're definitely going to want to work with us. And you know, we do support, you know, throughout in terms of asking us where you can have a little bit more, and generally, you know, within reason, you know, the answer is usually a favorable for whoever's in the field, you know, doing the work.
So, you know, again, and we showed you two types of systems that we offer with PRU. You know, this is our dual post adjustability, and again, same ideas, same premise here. You know, showing you the tolerances for both from the foot brackets. So you're going to have two here, north and south, and then essentially the adjustability up and down, east and west, north and south again for each one. All right, so wire management. We discussed a little bit about this, and here's the slide. So essentially, with our system, you're able to, follow your leads through our C channel that's there on site, against the purlins. We have notches in the purlins themselves for two different reasons. One is to, either clip or clamp the wires to the C channel so it doesn't go anywhere, right? So some people use zip ties, others use wire management clips, whatever it may be. The other one is for drainage as well. So we have some notches, on the south side of the purlins that are notched out and allow for drainage. We don't want any water pooling or sitting in that channel. So, something that's pretty, unique from us is that, we're actually using this C channel or this purlin for, two specific reasons here. And then on the bottom right-hand corner, you could also see that, you could actually route your wiring, through the C channels there, and there'll be notches in there where you're allowed to do that. So it just kind of helps with your wire management flow and things like that. Anything to add, Vishal?
No, I think it's pretty self-explanatory. Again, no additional parts or pieces required there, and it makes for a very, very clean install as well when you do it that way. So
perfect. So some certifications and testing, right? We get this sometimes from the owners of the sites, or developer comes with the bank wants to know, or somebody wants to know, right? Usually it's whoever owns the site in the end, are what are the certifications that this system has, and how do I know that it meets our standards and longevity, etc. So obviously ETL and UL certified systems. We've performed wind study testing with CPP, which is very important. Third-party mechanical testing of key components and connections. So making sure that all these connections hold up to standard over time, and stress factors over and over and over again. Of course, we also do our own internal load testing and R&D, and constantly enhancing the product as far as its performance and adjustability, ease of use, so on and so forth. So really a well thought out product is the end result that we're providing here, that will make your installations or your systems much cleaner, last longer, a really secure system for these sites.
So I guess we'll hand it over to Arash at this point to talk a little bit about foundation. And then there's some questions in the chat, and we'll definitely address your questions throughout, or the ones that are in the chat, and we can take more at the end as well. So
thanks a lot for that, both Vishal and Jonathan. If we could get the next slide. Oh, back one. Okay, so we're going to talk a little bit about foundations as it relates to solar mounting systems. Foundations represent one of the largest construction risks when building a solar farm. A lot of the other risks, financing, interconnection, biology, environmental, those can all get managed prior to the construction. However, the foundation risks is quite often something that's overlooked, and when that happens, quite often you're going to pay the price during the construction. So the risk of construction of foundation erection can be managed through appropriate studies ahead of construction and also ahead of procurement. I've talked with the Polar folks on many occasions, and I'm happy what I've shared with them on many occasions has resonated with them. Too often, a lot of racking companies, they specify that, their system works with this foundation and this foundation only, or, they're known as the ground screw guys or the driven post guys. The reality is you need to match your foundation with the subsurface conditions. If you don't, you could result in a lot of construction delays or construction challenges, or, even worse yet, potential foundation failures. So in terms of the subsurface investigation, to complete that, we highly recommend focusing on pre-production foundation testing programs. So this involves actually physically putting foundations in the ground, installing them and testing them to establish exactly what their capacity is. This is a little bit different than your typical geotechnical engineering approach. Geotechnical engineers are quite often known for having great use of boreholes, and where boreholes are a good tool that could be effective for these types of projects, definitely would say that they're less valuable than doing a foundation design test program. If I could get the next slide. So in terms of, what do we recommend to do in place of boreholes? We recommend doing test pits. The reason for this is with test pits, you're able to actually physically see what's below surface. From a borehole, you're inferring typically what is the subsurface conditions from a small, 4 to maybe 8-inch boring. Whereas a test pit is a large excavation where you can actually make a physical observation below grade. So you can quite easily note things such as boulders, cobbles. You may be into a non-greenfield site, so a brownfield where you've got fill, potentially refuse, garbage, construction waste, all potential risks that can, relate to foundation refusal. And from a borehole, like I said, you're making that you're inferring what the obstructions are, what's below grade from a small hole that's only about 4 to 6 inches. So for example, if you hit a boulder cobble that's 24 inches in diameter, it's a little bit unsure. You're a little unsure about what the size and the quantity of those potential obstructions are below grade. Typical foundations for solar mounting systems typically are driven foundations, helical foundations, ground screws. Can also see micropiles, which is essentially a round hole where you place the piece of steel in it and grout it either to surface or a set depth below grade. There was also some mention in this webinar earlier by the Polar team about ballast. So you can do cast and place ballast where you're forming a large mass of concrete and then placing the concrete right on site, or you can do a precast ballast where the concrete is being placed in a controlled environment off-site and then transported to site and put in place. There's other types of ballasts as well, geoballasts, or other types of earth ballast, but essentially a ballast is some sort of mass that's going to help resist your design loads. When designing the foundations for these systems, we're always considering the local climatic data and subsurface conditions. So with respect to local climatic data, we talked a little bit, the Polar team talked a little bit about it prior to this with respect to wind speeds and snow pressures. So those loads are applied to the actual physical rack, and then you're gonna have what we call racking induced loads applied from the racking system to the foundation. The other portion of it is your subsurface conditions. This is more of an issue or concern in northern environments where you've got frost the subsurface conditions and how it relates to the amount of frost add freeze is another thing that must be considered. We talked to the power of the pile load testing program. One of the benefits is that when you're doing an empirical design where you're basing it on calculations, a lot of the times you are you're inferring information from a borehole or a test bit, from in situ tests that have been completed in the field, and then determining soil properties from that to complete your foundation design. Whereas when you're dealing with a pile load testing program, you've got a finite known resistance of that type of foundation, and you're able to optimize the foundation accordingly. The other big advantage of doing a pile load testing program is actually determining the constructability and the feasibility of installing the foundation. So, you can do 100 calculations, but it'll never tell you it'll never tell you the success rate of the foundation. And that's very, very valuable information when dealing with construction of solar utility ground mount systems. And, at times you could be installing 10, 20, 30,000 foundation elements. And if you don't adequately assess the constructability of your foundation, and you run into an area where maybe 100 or 200 of those foundations don't work, that's a major risk, because that is going to do a couple things. Number one, it's going to slow down your schedule. Solar is very unique in the sense where it's the civil engineering world has met the manufacturing world, and you need to have that production line type construction. Without production line type construction, the process slows down. You may end up having an electrician coming in after your piling contractor, and if they don't got adequate areas to work in, that they could pull out site, they could demobilize, causing you a remobilization cost, or they could put you on standby. So not only is there the actual effect that determining the constructability has on the actual foundation erection, it's the first step in the actual erection of the solar mounting facility, and therefore can delay the whole project subsequently. And then, like I said, the difference between designing with pile load testing program versus using calculated values is that you're actually determining the capacity of the pile based on actually known pile capacities. And this allows for establishing the pile performance, and more importantly, optimizing your design. If you're reducing your foundation 6 inches, that can make a major effect on the overall bill if you're saving 6 inches on 10,000, 20,000, or maybe even $250,000 foundations. So small reductions in the foundation can lead to major cost savings. Can I get the next slide? So the design phase, will help you eliminate your risk, but that is not where things end. It's extremely important to have a quality assurance, quality control program in place during construction. This is to ensure that the conditions that you've assumed during the pre-production testing program as part of your final pile design are actually being achieved. If there's any changes in conditions, if you have a site rep periodically visiting the site, you're able to hopefully get ahead of the potential remediation requirements, or to avoid construction delays. This program can be completed, just to verify actual conditions, and in a lot of cases, financiers, project owners, developers, or if you're a subcontractor working for an EPC contractor, quite often they want some sort of sign off at the end of the foundation erection to verify that you've met the design. So by doing a quality assurance, quality control program, you're putting some documentation in place that helps the project team assure that or know that there's surety in the performance of the foundation, and then there's also the your own assurance that you're going to be walking away from a site and you've done everything in your power to make sure there's no failures. That's all from me. I'll turn it back to the polar racking team, and we can. I did see there was a couple questions. We can talk about those at the end of the presentation.
Yeah, so thank you, Arash, again. Some great insight there. So some common questions that we've been hearing lately, basically, is what we wanted to go through here, and then we're going to, of course, answer questions in the chat as well. I see there's quite a few, but really quickly, what's the availability and lead time of our products today? Used to be a little bit shorter, but today it's about 12 to 14 weeks from time of order. Will my price fluctuate from now until ordering? For right now, the price has stabilized a bit. Last year, we were seeing quite a hike in steel pricing. That has, of course, stabilized. It hasn't come down, but it also hasn't gone up. So a little bit of normality there has occurred. Next question is, will the Canadian convoy strike affect my lead times? And this is really to shipping, right? So shipping along with steel has been quite difficult. Shipping costs have gone up tremendously, as well as just finding trucks, finding containers, things to that nature have been an issue. We don't see an impact just yet on the Canadian shipping convoy strike. It's a smaller number of trucks out there, but again, we are keeping our finger on the pulse, and hopefully it gets better here pretty shortly. Next question is, how does the choice in racking impact the overall EPC cost? So again, with our system, we lower construction costs simply because we have less components, less risk for EPC, to get something wrong or something like that, delays, whatever it may be, less parts, less pieces, common hardware. Very important to keep everything moving quickly and efficiently and on time and on schedule. What is the impact of snow and frost when you're building in northern climates? So I think we covered this really, but two major important factors. One is frost heaving, and two is mechanical loading. So it's really important that you have a strong foundation and a strong racking solution in the northern climates, of course, right? And I think we're showing that our system does take care of both of those concerns. Opinions: single axis tracker versus fixed tilt. So some considerations there on topography, wind load, snow load, things like that do come up, versus single axis trackers allow for increased efficiency or production on the system, because of course we're tracking the sun throughout the day. We plan on big announcement coming up here beginning of April, and we'll probably add another webinar as well with our single axis tracker. Some really exciting and great news coming from Polar on that note, with a new and expanded product line that everyone could take a look at. And I guess we'll open it up to audience questions and kind of see what's in the chat and what we could do there.
So, yeah, sure. Before we jump to that, I know a lot of people have been asking us about single axis tracker versus fixed. This webinar is about our fixed product and general, just to expand on what what's here, topography and wind. If you have a site with a lot of topography, single axis tracker might not be the best option. Although our single axis tracker product that we're coming out with is specifically designed to accommodate higher topographies than what's on the market today. And the other thing, is wind and snow load. The other thing that's not mentioned here is O&M. If you have a single axis tracker sites, no matter who the manufacturer is or supplier is, are going to require a little bit more maintenance, because now you're going to have moving parts. So if you have like just one small site that, you're not going to be able to access quickly or get to quickly to, maintain it, take care of it, change a part, change a sensor, whatever it is, as these project life cycles are very, very long. So there is going to be some maintenance. So you might want to lean towards fixed than a tracker in that scenario. But if you have a group of projects and they're a decent size, and you have a good O&M company in the area, then then the tracker comes back into play. But generally, the heavier the loads, knowing that there's moving parts, you want to stick to fixed, unless again you're at a large site where you're going to have someone there to take care of it. So with that said, we will open it up to questions. Yeah, and for those of you that are going to leave soon, the contact information for Polar and PRI Engineering, and Jonathan, who's our director of sales in the US, and AJ, who's our Canadian Caribbean sales manager, is here on the screen. Well, with that in mind, yeah, so please feel free to reach out as your opportunities come up, and we'd love to talk to you and get more information and work with you. I will jump into some of the questions that are here in the chat, and you can continue to add. Janet, I will ask you, is there separate questions on LinkedIn that I'm not seeing on Zoom, or?
I think it's all together, Vishal.
It is all together. Okay, perfect. Yeah. That's great. That's.
I see that first question, I believe, is from Nicholas from LinkedIn. Asks, can you supply ground mount materials to the Southeast? So the simple answer is yes, absolutely. We could provide ground mount materials to the Southeast. Would love to look at that. Please let us know. Again, our contact information is up on the screen. And yeah, we could definitely take a look and help you with that.
Yeah, I see the next question is from Ken Sadi. He asks, I don't see PRED product available on BayWa US. So you're right, actually it's on the Canadian BayWa site. But if you email Jonathan, he'll connect you either with one of our Canadian distributors or one of the distributors who are about to take on here in the US, and get you set up and answer all your questions. So.
Next question is from Aziz on LinkedIn. How about solar harvesting on lakes? Any project references? So I guess my follow-up question to that would be, is it next to a lake, or is it like a floating system that you may be looking at? Just not sure. If it's close to a lake, I would say, yeah, absolutely. Again, we would want to see what the snow, wind load, and soil conditions are. Topography, and yeah, we'd absolutely be able to and willing to take a look and see what type of solutions we can make work there.
How high can the next question is from Ken again, how high can the leading edge be? Currently with our wind tunnel study, we can go up to 1.4 meters of leading edge.
What is that in inches, Vishal? Is that like 60 inches?
That's a really good question. Let me
for our US constituents?
Let me Google that. And,
just over 4 feet.
It's 52 inches.
Oh, so
52 inches.
Yeah. Perfect. Great. Yeah, so just over 4.5 feet, or just about 4.5 feet. So.
All right. Next question, Ben Grodorski. Are the edges of the notches in the purlins manufactured with a radius to avoid wire abrasion if using purlins for wire management? Vishal, you want to take that one?
Yeah, so what we found is when we roll it, they're not necessarily sharp edges. Keith, I mean, you can speak to this a little bit even better than I can.
Some inspectors do request you still put a protective edge on the edge of the steel beam just to ensure there is no abrasion later over time.
Yeah, but as it is, it's not necessarily sharp. So
As it is, it's not sharp, but still an inspector might request that you do that.
exactly. Thank you, Paul, for the compliments.
Question from Ben again. What frequency of test pits do you recommend? For example, how many per megawatt of system capacity approximately? I think that's a question for Arash from PRI.
Yeah, so I'll maybe answer that question and the following question kind of in one stroke. So the other question is there a minimum foundation field test to do per watt or per number of tables? So just dealing with a megawatt, rule of thumb would say roughly about 8 test pits, 8 pull tests. Where this answer gets a little bit complicated is if you've got homogeneous conditions, if you've got consistent results across the board, then that would be sufficient. However, if you're seeing a major amount of variability, then you may want to do some additional investigations, and that's where the typical numbers may not work. Just as an example, we work across Western Canada and the prairies. We work in the Northeast United States. If you're on a site in the kind of like upstate New York, glacial till plains, things might be a little bit more consistent than if you were in the Adirondacks in New York State, versus the Canadian prairies are extremely, extremely homogeneous. So, really depends on your geology. To go back to what the folks at Polar said, you ultimately always have to let your ground do the talking. And if your ground is throwing some conditions that may be concerning, i.e., soft organic deposits or high groundwater table or variable thickness to bedrock, then you may want to do some additional testing.
Great. Thank you, Arash, for that. All right. Question from Steve Ash. Oh, wait, we just did that one, right?
No.
So
there's one from the back. It says Farsi, who says, is the 6 east-west beam design allowed to direct bolt to all beams for high wind applications? Actually, we direct bolt to the 4 corners because that's where the holes are, and then we use a mid clamp down the center. So
that's a limitation of the module, essentially. So each individual solar panel typically has 4 mounting positions, 4 mounting direct bolt holes, and then for the third rail, we use those mid clamps like Vishal has indicated.
Yeah, and then the next one is from Steve Ash. What frequency of testing does PRI recommend for non-conforming piles as compared to the baseline quality control testing frequency? What is your maximum lateral deflection tolerance for fixed tilt racking as measured at the top of pile or ground?
Okay. So starting with that first part of that question, once again, I would not want to put any sort of number to that. The focus would be more so on trying to establish why the non-conformance occurred. That could involve a lot of tests. That could involve not a lot of tests, but essentially, we start by going back through the installation records. This is why as we noted, it's really, really important to have that quality assurance, quality control program. Typically, somebody on behalf of the contractor or the contractor's forces itself, so doing the quality control program. Somebody like PRI would do the quality assurance program. Starting with establishing what happened at those piles that did cause failure, trying to identify any trends, trying to identify if there's any design parameters that have not been achieved, any conditions that have changed, anything that was potentially different than what we would have determined during the design phase. And then once that difference has been established, then it's the matter of trying to identify other foundations that might meet that requirement, or might fall under the same installation category as the pile that failed. Barring the ability to kind of determine what those conditions are, or it seems like the information is a little random, then you may be into doing some additional non-conformance testing. Heard a lot of people use the term quadrant testing in the past. So what that means is, if you've got a pile that failed and you have no idea why it failed compared to its neighbors, then you may start testing the surrounding piles to see if it's an isolated condition on the site, or if it's just an isolated anomaly that caused the failure. With regards to the deflection, this is actually something that I do feel like the industry has some work to do. This parameter should come from the racking supplier. Every racking system is going to be different. The connections, the attachments are all different. Some of them have a lot of flexibility built into them. Some of them don't. I can, using Polar as an example, I can tell you that they've specifically done an analysis in-house where they were able to establish at what stage of pile movement would start to cause permanent and irreversible deformation of the steel structure. So that was found with the Polar system to be anywhere from 4 to 6 inches. When designing with the Polar system, for that reason, I assume a maximum vertical deflection of 45 millimeters with their system, but that doesn't necessarily hold true with other racking systems. Once again, it is going to be racking system specific, and typically companies that use slots and more adjustable connections are going to have more adjustability against deformations.
Yeah, that's great. Yeah, thank you for that, Arash. Next question from Red: what is the largest carport Polar's been involved with? Currently, we're working on a 1 megawatt carport in New Jersey, but we have worked on carports, in Canada, California, Michigan, New York State, Massachusetts, and New Jersey. So if you do have a carport you're looking at, please send over the information. Not sure if you're in Canada or the US, but the contact information is on screen right now. So a question from Adir: what are your standard table configurations? You have 2v12, 2v6, 2v18. Thank you. You know what? So we can do all 3 of those. We've done a lot of 2v25, 2v26 as well. Generally, if you tell us your string size, we try to match that and obviously optimize the number of piles as well, which with the modules getting bigger and bigger now, is a little bit of a balancing act. But again, if you send us your project details along with your string size and your topography, we'll work with you to come up with the ideal configuration. So any question from Scott: any plans to increase the low side heights, example being a ground mount in a retention basin? So something low tilt but high ground clearance, I guess 10
foot.
Yeah. So we have the carports, right? Oh yeah, it says ground there. Thank you, Scott. We have the carports as well. So and depending on what you want, we can definitely do that. It just takes us out of our basically one tunnel study parameters and forces us into using the building code loads, which generally make it a little heavier. But depending on the application, it's still would likely make sense. For example, in the Caribbean, we quoted a bunch of systems like this recently, which were going to be used. I guess it was like agro energy, they're calling it. So in farms where the system's elevated 10 feet, it's not a carport per se. Where we have a 3, in portrait, or L, or a 6 in portrait T. It was just a 2 in portrait. So we can do that. So if you want to send us the details, depending on the size of your project and where it is, we'll definitely get back to you and let you know what we can or cannot do. So
another question from Adir, follow-up question. What is the minimum size for a project to be interesting for polar racking? So, we have two different product lines that are very similar. Essentially, one is the PRU, which we showed you here today, really is meant for anything over 500 kW. If it's under that 500 kW, we would go to a more standard rack that comes with, more of a I should say, boilerplate stamping and design that kind of fits all needs. And that product is called PRUD. D stands for distribution. So we could do, smaller projects, let's say, 10 kW up to that 500 kW mark with the PRUD, and then anything above 500 kW would be a little bit more custom and fall into the PRU product line.
I think that's all the questions that we have today, and that takes us to 3:03, so an hour and a minute after we started. If there's nothing else, I think we can end here. There will be this presentation, I should say, will be available afterwards. We'll make it available afterwards, and we'll send you a link to that. And feel free to share it with your friends and colleagues. And again, please reach out to us when you have any opportunities, and we'd be very, very happy to work with you. So with that, thank you, Jonathan. Thank you, Arash. I appreciate you participating on this, and thank you as well to the people that you don't see in the background. Keith as well, our construction manager. Thank you for answering those questions, and the people in the background from our marketing team, Janet and Michelle. Really, really appreciate all your support here. So thank you very much again, and look forward to working with you all very soon.
Thank you, everyone. Have a great day.
Thank you.
Take care, everybody.